So this is complex numbers. And what we have to realize is this I is the square root of -1. And any time that we see I squared, that equals -1. I to the third is really I squared times I, so that's a negative I. And I to the fourth is just 1, because it's I squared times I squared, or -1 times -1. This is the foundation of complex numbers. The I is always equal to the square root of -1, not -1. So the first thing we do is we have to look at the square root of 49, -49. So I split it into its positive and its negative. So it's -1 times 49. Now, I know the square root of 49, that's 7. And I just learned that the square root of -1 is I. I'm done. 7i is my answer. When you're left with things like the square root of -75, I have to split -75. First, I take out the negative, and then I have to ask myself, 75. What two numbers multiply to 75 that I can find the square root of? And the easiest one is 25 times 3. The best thing you can do is write down those perfect squares from 1 to 15. Because I can find the square root of 25. That's 5. I can find the square root of -1. The one thing I can't find the square root of is 3. So I leave it inside the square root. And I'm done with that problem. 5i square roots of 3. In the last problem, I have -180 x to the third y to the 9th. I have to then break down the -180. So that's a -1 times, and I started asking myself questions. All right, what two numbers multiply to -180? All right, so I'm going to say 2 and 90, 3 and 60. None of those have square roots. And I keep going until I get a perfect square. And what happens is I can get 36 times 5, as long as I write down the factor tree. Just like I did when solving quadratics. 1 and 180, 2 and 90, 3 and 60, 4 and I forget. All right, 45. Okay, and I keep going until I get some perfect squares. And don't worry about the variables just yet. So I know the square root of -1. That's I. I know the square root of 36, that's 6. So I have 6i square roots of 5x to the third y to the 9th. Now, each time I'm doing a square root, I'm asking myself, what number times itself is this number? So I'm looking for pairs, really. I'm looking for two of a kind. So to handle the exponents, I do it very simply. I say, all right, I look at the exponent, 3. How many times does 2 go into 3? So what happens is 2 goes into 3 one time. So there's 1x on the outside. But it doesn't go in evenly. There's 1 left over. So 1x stays in. Y to the 9th. 2 goes into 9 4 times. So 4 y's comes out. And 1 y is left, because that's my... I can do another example for you with just variables. So let's say it's the square root of x to the 5th, y to the 11th, z to the 12th. Again, I ask myself, how many times does 2 go into 5? 2 goes into 5 2 times, with 1 left over. How many times does 2 go into 11? Well, 5 times with 1 left over. How many times does 2 go into 12? 6 times with nothing left over. So I am done with my answer at that point. I can also do some operations with these. So here I have two square roots that I can multiply together. What I do is I take out these negatives first. So it's I square roots of 12 times I square roots of 8. This way I can multiply my i's and get I squared. And I can also multiply inside the square roots to get the square root of 96. And I know I squared is negative 1. And then I break down the square root of 96. 2 times 48, 3 times 32. I could do 6 times 16. Because I know that the square root of 16 is 4. So I would be left with negative 4 square roots of 6. And then I'm done. Here, I'm just straight out multiplying. So what I do is I multiply the numbers. 5 times 3 times 7. That is 105. And that 3 is negative, so that's negative 105. And I times I times I is I to the third. But I remember back from my notes, I to the third is really negative I. So here I got two negatives, multiply those together, my answer is 105I. And that's where those I to the thirds come in. And when I'm reducing I to the 27th, I don't know what that is. But I know that I to the fourth is 1, so then everything's going to repeat. So if you remember back to elementary school, there was this thing called long division, and we do it here. So we take 27, and we divide by 4. So 4 goes into 27 6 times. 6 times 4 is 24, and then subtract them, and I'm left with 3. That means my answer is actually going to be I to the third, which is negative I. In my final operations with complex numbers or imaginary numbers are adding, subtracting, and multiplying. Adding and subtracting are just combining like terms. 7 plus negative 4, because those are the numbers with no i's, so that's 3. I plus negative 3i, that equals negative 2i. So my answer is 3 minus 2i. A lot of people can do that without even writing it out. Here, for subtracting, I do the same thing. 4 minus 7 equals negative 3. The trick is, here, this is negative 2i minus a negative 6i, which these double negatives become a plus, so I'm left with 4i. So my answer is negative 3 plus 4i. And the final one is multiplying, and that is when I FOIL. So I do 4 times negative 5, negative 20. 4 times 6i, plus 24i. 3 times negative 5i is negative 15i. And 3 times 6 is 18i squared. So I combine the middle part, because they're the ones with the i's. So I got negative 20 plus 9i plus 18i squared. But again, that I squared is there, and I squared is negative 1. So I replace that in. So it now becomes 18 times negative 1. 18 times negative 1 is negative 18. And then I can combine these numbers and get negative 38 plus 9i.